So in today's video, we're going to be talking about periodic trends. We're going to talk about 4 different trends, so I'm going to use 4 different colors just to make it a little bit clearer. The first trend we're going to be talking about is something called atomic radius. Now when we talk about radius, think about a circle. The radius is the distance from the center of the circle to the outside. The atomic radius is the same thing. It's going to be the distance from the center. And remember, the center of an atom is the nucleus. And we're going to be measuring to the outside of our atom. So it's to the outermost electrons. So remember, we've got our 1s, our 2s, our 3s, or 1s, 2s, 2p orbitals all the way out. So we're going to the furthest out orbital where the furthest electrons live. Okay? So here's the way it works. As I move down a group, so from the top down in a column, okay, atomic radius is going to increase. So the reason that it's increasing is because of those electrons. If I'm looking at my first group starts with hydrogen. Hydrogen has its nucleus, and then it's going to have 1 electron in the 1s. If I move on, my next element's going to be lithium. Lithium is going to have its nucleus. It'll have 2 electrons in the 1s. Then it's going to have 1 electron in the 2s. See how the distance is getting bigger? If I went down to my next element, so now I'm looking at sodium. Sodium's going to have its center with 2 electrons in the 1s. It's going to have 2 electrons in the 2s, as well as 6 in the 2p. And then it'll have 1 electron in the 3s. So see how we keep adding these electron orbitals and it keeps getting progressively bigger. Okay? So I'm going to add to my periodic table atomic radius. And it's increasing. So as I move down a group, atomic radius is getting bigger. As I move across left to right, atomic radius is going to decrease. Here's why. In this case, all of my atoms are going to have electrons in the same outer orbital. So for example, if I'm looking at boron, boron's going to have its nucleus and 2 electrons there. Then it'll have 1 electron. If I was looking at carbon, it's going to have its nucleus. It's going to have 2 electrons. And then it's going to have 2 more. If I have nitrogen, it's going to have its nucleus. It's going to have 2 electrons. And then it's going to have 3 more. Now these should all be the same size. I can't draw circles the same size, but they all have electrons living in this 2p orbital. So it's the same distance away. The only thing that's changing is the number of protons. What's happening is the number of protons increases. Now remember, my positive protons and my negative electrons are going to attract. And because I'm going from 3 to 4 to 5 protons, I'm going to have more positive pulling in, and it's going to be pulling from the same distance. So this is going to get progressively smaller as the number of protons increases. Okay, So I'm going back to my periodic table, and I know that atomic radius decreases. Now the way this works, elements with the smallest radius will be on the top and the right. So up here, helium is going to be my smallest. Elements that have the biggest radius will be at the bottom and to the left. So francium is going to have the biggest radius. Okay? So the next thing that we're going to talk about is ionic radius. So I'm still talking about a radius. So it's still going to be the distance from the center of the atom but this time it's not a regular atom, it's an ion. It's still the center of the nucleus to the outermost electrons. Okay, so it's the same thing as before, only now I've got an ion. Now remember, I've got two types of ions. I can either have a positive ion or I can have a negative ion. If I have a positive ion, it's losing negative electrons. Because it's losing electrons in the outer shell, it's going to get smaller. If I have a negative ion, it's going to gain negative electrons. Since it has more electrons in the outer shell, which are going to repel from each other, it's going to be bigger. So if I had something like a sodium atom versus a sodium ion, my atom is going to be bigger than my ion because it lost electrons. If I had a fluorine atom and a fluorine ion, my ion is going to be bigger because this time the negative gained electrons. Okay? Now, because I'm still talking about radius, it still works the same way as regular radius. If I'm moving down a group, ionic radius is going to increase for the same reason it did before. I've got more electron orbitals. As I'm adding electron orbitals, my atom's getting bigger and bigger. As I move from left to right, my ionic radius is going to decrease because I have more positive protons. So let's go ahead and add that to our periodic table. As I move down a group, my ionic radius, increases. As I move across a period, my ionic radius decreases. Okay? So both of these trends go the same way. They increase together, they decrease together for the exact same reason. I have more electron orbitals, I have more protons. Okay? So ionization energy is the energy required to remove one electron. So I'm making something turn into a positive ion. Okay? As I move down a group, ionization energy is going to decrease. Now let's think about why. We said that as we move down a group, my atoms are getting bigger and bigger, which means the electrons are further and further away from the center nucleus. And remember, my nucleus has my positive protons. The positive protons are the only thing that's pulling in on those electrons. So as I get further and further away, there's less pull. So as I get further and further away, it's easier to steal them away. Okay? So the electrons are farther away from the positive protons. So there's less attraction to the nucleus, so it'll be easier to steal. Okay? As I move left to right then, it's going to increase. Now, when we talked about moving left to right, we said they're all about the same distance away. They're all in the same outer shell. But now there are more positive protons. Because there are more positive protons, there's going to be a greater attraction. Okay. So let's go ahead and add that to our periodic table. I know as I move down a group, ionization energy is going to decrease. As I move left to right, ionization energy increases. So the radius and the ionization energy are opposite. As the electron moves further away, it's easier to steal. As the electrons are closer to the nucleus, it's harder to steal. Okay? Last concept. So electronegativity is the tendency of an atom to attract electrons. So if I'm bonded with another atom, how likely am I to steal that electron? How tight am I going to pull the electrons in a bond? How close am I holding my electrons? So ionization energy and electronegativity are kind of opposites. Ionization energy, I'm trying to steal an electron. Electronegativity, I'm trying to pull electrons towards me. So as I move from the top down, my electronegativity is going to decrease. Okay? Now if I think about it, as I'm moving down a group, it's getting bigger and bigger. I'm not even holding on to my electrons really tight, so it's not going to be easy for me to steal electrons or pull other electrons towards me. Okay? So let's put that in. As I move left to right, what's going to happen is electronegativity is going to increase for the same reason that my radius decreased. I've got more positive protons pulling things in. They're going to pull tighter on the protons or on the electrons that I already have. It's also going to pull tighter on other electrons. Okay. So you will need to know these trends. Not only will you be responsible for identifying which element has a bigger radius or which element has higher electronegativity, you'll have to be able to explain why. So make sure you understand what's happening.